Every single year in factories all across America, people lose fingers, hands, sometimes their entire arms, to machinery. And what's crazy is that a lot of these machines actually had guards. Some were taken off for, convenience. Others were bypassed years ago and just never put back. Machine guarding is consistently one of OSHA's most cited standards, but it's also one of the most ignored. So today, we're going to get into exactly why these hazards are so incredibly dangerous and what the law actually requires to keep you safe.
Let's just start with a number that should make you pause. 18,000. According to OSHA, that's how many of your coworkers suffer amputations, serious lacerations, and just awful crushing injuries every single year. These are not just numbers on a page. Think about it. Those are 18,000 lives that are changed forever.
And if that number wasn't staggering enough, it gets worse. On top of those 18,000 injuries, more than 800 people don't make it home at all. They're killed in what are almost always preventable incidents. That's more than 2 people every single day of the year.
And here's the part that is just absolutely tragic. Most of these incidents, they happen on machines that had the proper guards. They were just removed for a quick fix or bypassed because they were slowing things down. This isn't just some obscure rule in a book. It is a critical safety system that, when it fails, has catastrophic results. It's no wonder it's one of OSHA's top violations year after year.
So, to really get a handle on this, here's how we're going to break it all down. First, we're going to look at the anatomy of a hazard, so you know exactly where the danger is hiding. Then, we'll cover your first line of defense, which are the different types of guards out there. After that, we'll dig into when good guards fail, basically how things go wrong in the real world. And we'll wrap up with the most crucial part, owning your safety zone and the power you have to prevent a tragedy.
All right, let's jump in. First things first, you have to understand where the danger is. It's not like the whole machine is out to get you. The danger lives in very specific, very predictable places. We're going to break down the 4 main hazard zones you've got to be able to spot.
First on the list is the point of operation. This is, the business end of the machine. It's where the work gets done. So think of the blade on a saw, the die on a punch press. That's the spot. It's designed to cut, shape, or bend steel. And trust me, it'll do the exact same thing to your hand, no questions asked.
Take a look here. On the left, you've got a bending operation. The danger is right where that punch comes down. On the right, it's a shearing machine, and the hazard is that blade. Totally different machines, totally different jobs, but the principle is exactly the same. That's the danger zone, and it absolutely must be guarded.
Okay, next up, power transmission components. If the point of operation is the business end, these are the parts that give it all its power. We're talking about the belts, the gears, the pulleys, the shafts. A lot of times they're kind of tucked away on the side or the back of the machine, so it's easy to forget about them, but they are channeling all the force of that motor.
And here's a perfect example. You see this all the time, and it is a massive red flag. An unguarded belt and pulley. Yeah, it might seem harmless just spinning away, but that thing is literally designed to grip and pull. It'll grab a loose sleeve, your glove, or your hair in a fraction of a second. And once it has you, it is not letting go.
Then we've got a sort of catch-all category, other rotating parts. This is stuff like flywheels, spindles, rotating shafts. And let's bust a huge myth right now. A lot of people think if it's turning slowly, it's safe. That is dead wrong. Even a perfectly smooth, slow-moving shaft has enough torque to snag your clothes and pull you in. Let me be crystal clear. There is no such thing as a safe speed for an unguarded rotating part, period. All right, and finally, we have what might just be the most deceptive, most dangerous hazard of them all, the in-running nip point. This is any spot where 2 rotating parts meet, or where a rotating part meets a stationary object. Think rollers or a belt going around a pulley. It creates this point that just draws things in. It's like a mechanical Venus flytrap. Once you touch it, physics takes over, and I promise you, you can't win.
Which naturally brings up a really critical question. We all like to think we're quick, right? That we have good reflexes, that we could pull our hand back in time, but I want you to ask yourself honestly, can you really? Are you faster than the machine?
Let's just look at the science, because the numbers here do not lie. On your best day, the absolute fastest a human being can react, from seeing danger to sending a signal to your muscles to move, is about 200 milliseconds. But a nip point? It can grab your finger and pull it in under 50 milliseconds. Do the math. The machine is literally 4 times faster than your reflexes. It's not even a fair fight. By the time your brain has even figured out there's a problem, it's already over. Escape is impossible.
So if you can't rely on being fast enough, what can you rely on? The answer is engineered controls.
Your first, best, and really your only line of defense is the guard itself. So let's run through the 4 main types of guards that OSHA talks about in the 1910.212 standard.
Alright, first you've got fixed guards. Super simple. It's a physical barrier that's literally bolted or welded onto the machine. Can't get more reliable than that. Second, you have interlocked guards. These are the smart ones. Think of the door on your microwave. You open it, the machine stops. Perfect for areas you need to get into sometimes. Third are adjustable guards. You see these on things like bandsaws, where you can move the guard to fit whatever size material you're cutting. And finally, self-adjusting guards, like the one on a table saw that lifts up as you push the wood through.
Now this is so important to understand. Proper guarding isn't just about slapping a piece of plexiglass on a machine. It's a science. OSHA has these super specific tables, like this one here, that tell you exactly how big an opening in a guard can be based on how far away it is from the danger zone. The closer the guard is to the hazard, the smaller the opening has to be. It's all engineered down to the millimeter to make it physically impossible to get hurt.
Okay, so we've identified the hazards. We have these amazing, scientifically designed engineering solutions to protect us. The system should be foolproof, right? But we all know it's not, because even the best designed guard in the world can be defeated by one thing, and that's human behavior. Let's talk about how these perfect systems fail in the real world.
This quote right here really nails it. The ultimate goal is to design machines where being safe isn't a choice you have to make. The safe way is the only way to operate it. But, we don't live in that perfect world just yet. And every single day on every shop floor, people make choices, good ones and bad ones.
So let's play out a classic story, one that happens all the time. Maintenance has to get into a machine, so they take off a fixed guard. They do the repair, but they leave the guard sitting on the floor. They'll get back to it in a little bit, right? Well, a little bit turns into the rest of the shift, then a week. The next operator comes in, sees the machine is up and running, and just assumes it's safe. They have absolutely no idea they're walking into a trap.
Or how about this one? This scenario is even scarier, because the danger is completely invisible. An interlocked guard keeps tripping and stopping production. So to keep the line moving, somebody puts a jumper on the switch. It's just a temporary fix until the new part comes in, but that part never gets ordered. Now the safety system is completely defeated, but the guard looks like it's perfectly fine. It's nothing but a decoration. It offers zero protection.
And then there's maybe the most common failure of all, complacency, the simple shortcut. A worker needs to adjust a part, and instead of taking the 10 seconds to stop the machine, they just quickly reach around the guard. They've done it 100 times before, no problem. But that 101st time, their timing is off by a split second, and that shortcut instantly turns into a life-altering injury. It's like playing Russian roulette with the machine. And all of this leads us to the final and honestly, the most important piece of this entire puzzle. All the engineered guards and all the safety rules in the world are absolutely essential, but they are not enough. The single most important safety feature on any machine isn't part of the machine at all. It's you. It's about building a culture where every single person on the floor owns their safety zone. So let's boil it all down to the things that are completely non-negotiable. First, you never, ever operate a machine unless all of its safeguards are in place and working. End of story. Second, you never, ever defeat a safeguard. If it's malfunctioning, that's a warning sign. Stop work and report it. Third, if you see a guard that's missing or busted or just doesn't seem right, you speak up immediately. Fourth, know your machine. Understand its specific hazards. And finally, and this is the big one, look out for each other. You have to be your brother's keeper out there. At the end of the day, remember this. The machine doesn't think, it doesn't have reflexes, and it sure doesn't care if you're in a hurry to meet a quota. All it does is what it was built to do, over and over and over again. Your knowledge, your attention, and your choices are the only thing standing between a totally normal shift and a trip to the emergency room. Make the right choice, every single time. And if you want to keep learning how to do that, subscribe to HSC Study. Stay safe out there.